We looked at the parameters of the MLP classifier. Now let's see how we can use it to classify data. So first we're going to import pandas so we can read the data. And we're going to import the MLP classifier. This is done, so we import it from scikit-learn. It's in the neural network module, and we want to import the MLP classifier. Additionally, we're going to import some metrics that we can use to see how well our classifier works. So this is also included in scikit-learn in the metrics module. We're going to import the precision, recall, and F1 spot. Right now, let's read the data. Get pandas. So in this case, in this example, we already have the training and data split. So we're just going to read them in separately. If we look at the data, this is an ambient assistant living dataset for activity recognition. So we have data from various sensors. We can see we have a lot of dimensions here. So this dataset has 563 columns, and we're going to use all of them except for subject, which doesn't give us any info in terms of classification in this case. And of course, the activity will be used as the output or target variable which we want to predict. So first we want to split this into training into X and Y. So X will give us the training, so the training attributes, and Y will give us the target variable or output. So here we want to take all columns except for subject and activity. We're gonna do it like this. Now if we look at X, we see that it includes everything up to this, so this attribute here. And we want to take Y. This is just gonna give us the activity. So now we can initialize the MLP classifier. In this example, we're just going to use the default parameters for, so the default value for all parameters, and we want to see how this is gonna work. So in order to train this neural network, we're just going to use the fit function. So we're going to use the fit method, and we pass in X and Y, and this will just train the neural network. So now the neural network is trained. So next we want to test it. In order to do this, we're going to need some test data that we're going to read in now. And we're going to split it the same way we split the training set. So y-test will give us the correct the correct labels for each training sample. Right now we can see what the score is, or with MLP score will tell us how many of the test samples are classified correctly. We're going to pass in the test data, and you'll see that we got an accuracy of 94.6%, which is a fairly high accuracy. However, the accuracy doesn't always give us the complete picture, so we're also going to look at the precision, recall, and F1 score to see what the score is, to confirm that our classification really is good. So in order to do this, we're going to take the labels that the neural network predicts for the test samples, and then we're going to look at all metrics. So we're going to compute the accuracy again the same way. Then we're going to look at the precision using the precision score. So here we'll pass in the correct labels and the predicted labels. And since we have a multi-class classification problem here, so if you look here, okay, so here only 2 of the classes are shown, but we have 6 classes in this data set, so we're going to need to average the precision score across all of these classes, and we're going to use a weighted average. We need to do the same thing for the recall and F1 score. So compute the recall score for Y test and the predicted labels, again with a weighted average. And F1. So now we are going to compute all of these measures, and now we want to print them and compare them. So now if we look at all of these measures, we can see that they're all high, so we don't have a very high number of false positives or false negatives. The number of mistakes for each class is balanced. That means that we don't classify all samples as one class which is dominant in the training set, but instead we get an actually good classification with high accuracy, precision, recall, and F1 score.